We hear the term artificial intelligence thrown around all the time, but what does it really take to build it? Well, today, we're going to pull back the curtain. We're going to move past the sci-fi and get right down to the spreadsheets to see the real practical work that actually makes AI tick.
So, when you hear AI, what's the first thing that pops into your head? Is it something helpful, like Siri on your phone? Or is it something a little more Skynet? This question, right here, it gets to the absolute heart of the matter, because the AI we actually have today is fundamentally different from the AI we see in the movies.
Okay, so let's get a baseline. What are we really talking about here? Well, if you strip it all down, AI is just a field of computer science that's all about creating systems that can learn, that can reason, and can solve problems. All those things we typically think of as uniquely human. The end goal? It's really to automate complex stuff and, hopefully, help us all make better decisions.
And this brings us to a huge distinction. See, the AI we have right now is what we call narrow AI, or sometimes weak AI. Think of it as a specialist. It's incredibly good at one specific task, like recognizing your face or answering a question. It operates in a really limited box and has zero self-awareness. And here's the kicker. It's the only type of AI that actually exists today. The other kind, general AI, that self-aware HAL 9000 style intelligence that can do anything a person can, that's still completely in the realm of science fiction. For now, anyway.
Okay, so if today's AI isn't self-aware, how in the world did we teach it to think?
Well, the journey to get here has had 3 big chapters. It all started with something called good old-fashioned AI, or GOFAI for short. You can think of this as the rulebook era. Programmers would literally write an if this, then that rule for every single possible scenario. Super rigid. Then things got interesting. We entered the machine learning era, where AI became a student. Instead of giving it rules, we just gave it a ton of data and said, here, you figure out the patterns. And that leads us to where we are now, in the age of deep learning, which is basically AI modeled on the neural networks of the human brain itself.
Now, to really get a grip on how these systems work, it helps to think of them as an intelligent agent. It's a really simple but super powerful idea. Basically, an agent observes its environment using sensors, it makes a decision based on that information, and then it acts on that environment using its tools, which we call actuators, all to achieve some kind of goal.
Let's make this concrete. Think about a robot vacuum. Its goal is simple: clean the floor. Its sensors? Those are for detecting dirt and bumping into walls. And its actuators? That's the wheels and the suction motor. It's a perfect, everyday example. And honestly, every AI, whether it's this little vacuum or a massive self-driving car system, can be broken down using this simple model: sense, think, act.
All right, so we've got the concept of an agent down. But how do you go from that idea to actually building one? Well, for pretty much all of today's AI, the answer almost always starts with a programming language called Python.
Before any AI can start learning, you have to get its data organized. And in Python, we do that using something called data structures. The easiest way to think about these is just as different types of containers. Each container is designed to hold and organize information in a very specific way. And just like in your kitchen, you have different containers for different jobs. Some are just simple lists, ordered and sequential. Others are built to only hold unique items, no duplicates allowed. And then you have some, called dictionaries, that work kind of like an address book. They let you look up information super fast using a unique key. The main takeaway here is that choosing the right container for your data is a really critical first step if you want to build an efficient AI.
And that brings us to the single most important ingredient in any AI system: the data itself. Data is the fuel that powers all of machine learning. But, and this is a big but, it's also the source of its biggest headaches.
You've probably heard this old saying from computer science, and it has never been more true. Garbage in, garbage out. An AI model is only as good as the data you train it on. If you feed it messy, inaccurate, garbage data, you're going to get garbage results. It really is that simple.
So, how do we solve this garbage data problem? Well, the solution has a name. It's called data preprocessing. Now, this is the unglamorous, behind-the-scenes work of turning raw, messy information into a clean, structured data set that an algorithm can actually use. And get this, it's not a small part of the job. A lot of data scientists say this can take up to 80% of their time on any given project.
And this isn't just about being tidy. There are 2 massive payoffs for doing this work. First, clean data directly leads to a more accurate model,
No surprise there. But second, algorithms can train way faster on well-structured data. So it's a critical step that saves you a ton of time and just flat out produces better results.
So, okay, how do you actually do it? How do you wrangle all that messy data and get it into shape? Well, it's a pretty methodical process. It usually follows 4 key steps. First, you've got data cleaning, getting rid of the junk. Then there's data integration, which is where you combine data from a bunch of different sources. After that, you have data transformation, where you get everything into a consistent, useful format. And finally, you might do some data reduction to shrink the data set and make everything run a little faster.
Out of all of those, data cleaning is probably the most critical part. This is where you deal with things like missing values. Maybe a sensor glitched and left a big gap in your data. You have to figure out, do I delete this whole row, or do I try to fill in the blank with an educated guess? It also means hunting down and removing duplicate entries, or getting rid of those crazy outliers that could completely skew your results.
Okay, but once your data is perfectly clean, how do you know if your model has actually learned anything? I mean, that's the million-dollar question, right? You've spent all this time preparing the perfect data set, you've trained your model, but did it actually learn the real patterns, or did it just cheat and memorize the answers?
And here's the absolute golden rule of evaluating any AI model. You have to test it on data it has never seen before. It's like giving a student a final exam with questions they didn't see in the textbook. This is the only way to simulate how the model will perform out in the real world when it comes across brand new information.
The standard way to do this is called the train-test split. It's simple. You take your whole data set and you slice off a piece, usually about 20%, and you hide it. The model gets to learn from the big 80% chunk, the training data. Then, when it's done learning, you bring out that hidden 20%, the testing data, and you give it that final exam to see how well it really performs.
Okay, let's zoom back out and bring all this together, from the big, futuristic ideas all the way down to the nitty-gritty of building a working model.
So it turns out the journey from that sci-fi dream of an intelligent machine to a real working AI that can solve actual problems, well, it's paved with spreadsheets, not stardust. It's built on a foundation of the meticulous, sometimes tedious, but absolutely essential work of cleaning, structuring, and preparing data.
In the end, the secret to powerful AI isn't some magical black box. It really just comes down to the quality of the data we feed it. So if we know that great AI is built on great data, the real question becomes, what's the next big problem we want to solve with it?